Alright, so what I'm going to do here is go through the solution to the sample questions I gave you guys for the final exam for Algebra 2. This one happens to be the Honors Algebra 2 packet. Some of you have the other packet which has fewer questions, and some of the questions are a little bit different. But I'm going to go through this solution, and you'll be able to use this for both probably. So make sure you're looking at the right problems here. Again, the non-Honors Algebra 2 classes have a different looking packet. And for the most part, it's the same questions. There are a few that are different. So go along with this one and take a look. So first, the first problem says, if 3x plus y equals 19 and x plus 3y equals 1, then what is the value of 2x plus 2y? So this is a tough problem because a lot of people think that they have to solve simultaneous equations. And some people might say, all right, well, I have two equations, two variables. I can either, solve them with substitution, elimination, or a matrix. So you could even use a matrix and write 3, 1, 19. And you can write here 1, 3, 1. Okay, you can do RREF of this and come out and give yourself a matrix, okay, with the x and y values. But that's not needed actually for this problem, because what I notice is this. I'm asked for 2x plus 2y. And if I simply look at the equations I have, I can just add them together. And when I add them together, I'm going to say, okay, well, 3x plus y equal 19, x plus 3y equal 1. Add those two equations together like an addition problem. You're going to get 4x plus 4y equals 20. Well, if 4x plus 4y is 20 and I want 2x plus 2y, I could say to myself, well, I just divide the whole thing by 2. And here I'm going to get 2x plus 2y equals 10. Okay, similar to your SAT type problems. So there's no need to solve for x and y here and then get a solution. You could do that, and that's not a problem. Go ahead and solve for it, and then just take 2x plus 2y and add them together. Problem 2. Which of the graphs below represents the following situation? A football is kicked from the top of a building into the air and lands on the ground below. Well, let's think about this first. It's kicked from the top of a building. This would be like it's kicked from the ground, and it's punted, like by a punter in the NFL, kicks from the ground, and then the returning team receives the ball and then runs it back. This is from the ground, though. Next, here it looks like a ball would have to be thrown at an angle straight down and somehow stay at a linear function. But as we know, objects or projectiles follow a parabolic path. This is a linear path. That's also out. Next, here I can see that I have part of the problem correct because I'm starting at some elevation or at the top of the building, but there's no way I can kick a ball. It could go down and then suddenly just shoot back up and defy the laws of gravity. So that's not even logical. The only answer that makes sense is choice B. You start at the top of the building, you kick the ball, it reaches its max height at this location, it then comes down until it reaches the ground. Here's your building on the side. Choice B is our answer. Number 3. What is the effect of the graph of the equation y equals x squared plus 1 when it's changed to x squared plus 5? Well, take a look, people. Right away, this 1 became a 5. And if you remember, this is really your y-intercept. Your y-intercept here would equal 1. Your y-intercept here would equal 5. So what's happened really here is that you've taken the graph and you've gone from a y-intercept of 1, which is like this, to a y-intercept of 5, which is like this. So it looks to me like the whole graph shifted up. So we have a vertical shift upward of 4 units. Okay, so we take a look at choice C. It's the only one that makes sense. The graph is congruent, and the vertex moves up the y-axis. Here was our vertex right here. Our vertex has now moved up the y-axis. Again, what could you do here? You don't have to know these graphs by memory. You could simply graph in your calculator. You should know by now the general shape for sure. So let's graph x squared plus 1, and let's graph x squared plus 5. Graph them together. Let's hit zoom 6, and we'll take a look. There's x squared plus 1. There's x squared plus 5. And if I change my window settings to see even further up, which I can do, make this maybe, let's say, 20 for now, and graph. There's our first one again, and there's our second one there. Same exact graph, nothing has changed, it's just shifted upward. It's just shifted upward. Number 4, simplify completely. And simplify clearly means we're not solving for a variable. When it says simplify, or if it says rewrite or simplify the expression, that's when we're rewriting it or making it look nicer. If it said solve the equation, we would need an equal sign, and then we would solve for x. But this just says simplify. If you want to subtract two fractions, you need a common denominator. We clearly have that. We've got a common denominator in both spots. So I write this as 4x minus 7 minus 5x minus 11 all over the common denominator of x squared minus 16. And many of you are noticing already, well, x squared minus 16, that rings a bell. This triggers, in my mind, dots. So there's a good chance I'm going to end up factoring this into x plus 4, x minus 4. Okay, but let's look at the numerator before we do that. So the numerator, we have 4x, we have a minus sign in the middle. Make this a plus sign, and make this a negative, make that a positive. Again, subtraction is defined as adding the opposite. So make it a plus sign in the middle, and make the other two negatives. I've got 4x plus a negative 5x is negative 1x. I've got negative 7 plus 11, okay, negative 7, again, plus 11. If I think about this, I'm saying I'm starting at negative 7, I'm going up by 11. Okay, so I'm going to end up at positive 4. So right now I've got negative x plus 4 all over x plus 4, x minus 4. Okay, that's what we have for this kind of a problem. Well, at first it looks like I can't do anything with that, and that's not a choice, but notice, and you remember from class, this is really thought of as 4 minus x, because negative x plus 4 is the same thing as 4 minus x. Well, I have 4 minus x and x minus 4. These two things cancel, leaving behind a negative 1. Remember, when you cancel two things like, if you cancel a minus b over b minus a, that just results in negative 1. So when I cancel those two, I'm left with negative 1 over x plus 4, which is choice B. Okay, choice B. Number 5, there are more than one way to do this. There is more than one way to do this problem. The first thing I would look at is say to myself, well, I can't have a negative under the radical. So I have to start by saying my domain is limited by the fact that x minus 3 must be greater than or equal to 0. Okay, again, clearly I cannot have a negative because negative under the radical is imaginary. You cannot graph something that is imaginary. So the domain has a limitation. It must be greater than or equal to 0 or positive. I can add 3 to both sides. I get x is greater than or equal to 3. That's one way to do this problem. Another way to do it is to go to your calculator and graph it, or graph it in your head. Remember h and k. We've got a vertical shift up 2. We've got a horizontal shift to the right 3. So I go up 2, that's my k value. I go to the right 3, because my h, I do the opposite. I put my vertex, and that's my square root function. Again, my square root function, why is it going down below? Because it is negative. Okay, because it is negative. So look at the negative branch. So I can see clearly that my domain starts here at 3 with a closed circle and goes on forever. Well, everything bigger than 3 is just x greater than or equal to 3. If you didn't know how to graph this off the top of your head, again, go to your calculator, graph it, take a look. You'll see the same thing. Number 6, the relation 3, 4, x, 5, 6, 7 is a function. What values, if any, may x not assume? So what values can x not be? Okay, it says it's a function. Well, if you remember a function here, for each input, we must only have one output. For each input, we must only have one output. So, when we take a look at this problem here, we start by saying, all right, well, I've got an input of 3, and that corresponds to 4. I've got some other input of x that corresponds to 5. I've got another input of 6 that corresponds to 7 here. Now, for this kind of a problem, what I'm going to notice is this. If each input can only have one output, that means that 6 can only become 7. So x cannot be 6, because then 6 would become 5, or 6 would have an output of 5. Also, 3, its output is 4. So if I make x equal to 3 here, then its output would also be 5. So 3 and 6 cannot have another output. So what values, if any, can x not assume? X cannot be 3, x cannot be 6, because if you put a 3 or a 6 here, it means its output is now 5. And we know that for functions, each input can only have one output. So pretty much you can't repeat your inputs. You can't repeat your inputs. So 3 and 6 cannot show up more than once there. Number 7, if the lines containing the points A4 and B2 have a slope of 1/7, then the quantity A minus B is equal to which of the following? Right away, please think about the fact that you're not solving for A, you're not solving for B. You're solving for A minus B. So let's go ahead and do this. We've got slope. The definition of slope, A equals delta y over delta x. And for this case, I'm going to use M, even though all year I used A, just because I don't want you to think of A, the variable. Slope is delta y over delta x. Well, the slope is 1/7, and that equals change in y. Change in y, well, this is y2 minus y1. which is 2 minus 4, over x2 minus x1, which is b minus a. This is, x2 minus x1 is going to be b minus a. Well, I can do the problem like this and solve it, and that's fine. But if you remember from slope, I don't have to do x2 minus x1 or y2 minus y1. I can switch them as long as I'm corresponding. So I can do simply this, and this is the reason I'm going to show you. Call this x2, call this y2, call this x1, call this y1. And now you'll notice you do y2 minus y1 in the same problem here, same thing we're going to have here, but now we're going to have 1/7 equals 4 minus 2 over a minus b. Again, think of this as 4 minus 2, y2 minus y1. A minus b is x2 minus x1. The reason I did that was because look at the problem. It says a minus b equals what? So we're going to have to find a minus b. Well, this was b minus a. I don't have to deal with that later on. So make it easier, use the other one. Now, at this point in time, all we got to do is either one of two things. We can cross multiply, or we can just move stuff around. And if you remember what I've taught you guys this year, you can always move the diagonals. So you can switch these two spots every time. So just move them. So write it as, I'm going to write down here, a minus b over 7 equals 4 minus 2 over 1. Well, I want a minus b by itself. A minus b is currently being divided by 7. So I need to multiply both sides by 7. So I need to multiply both sides by this quantity to get rid of it. So if I multiply by 7 on both sides, these 7's cancel. So it's pretty much the same thing as taking the 7 and bringing it over here up top. 4 minus 2 is 2. 2 times 7 is 14. You have 14 divided by 1, which is just 14. So a minus b equals 14. All right, number 8. Which of the following shows the expression in its factored form? Well, right away, people, right away, take a look at this problem. Right away, think AC method. Why is it AC method? Because the A value is a non-unity value. Remember, non-unity means not 1. And when it's a non-unity value, start with AC method. So AC equals 4 times 21. Well, negative 21. 4 times negative 21 is going to be negative 84. That's the AC value. The B value is negative 80. So we have to think to ourselves, what numbers multiply to give us negative 84, and what numbers add up to give us negative 80? Well, you might be stuck at this point and not really know. So think to yourself, well, what are the values that I can break 84 into? If you don't know what 84 breaks into, please just go to your calculator. Second quick, let's go back to our home screen. 84 divided by 2. Well, that's going to be 42. 42 and 2 don't add up to 8, though, so that's not going to work. 84 divided by 4. 21. Well, 21 and 4, that's what we had in the beginning. 21 and 4, those don't add up to 8 either. What about 84 divided by 6? Does that work? 14. And think about it. What's 6 and 14? 6 and 14 can give you 8. So let's go back to our problem now. Again, we have AC equals negative 84. We have B equals negative 80. So go ahead and think to yourself, this can be broken, again, into 14 and 6. Because 14 times 6 gives you 84. Well, one of those needs to be negative. I'm going to put the negative here because I want the quantity that's larger to be negative, because when I add them together, I'm going to get a negative number as well. So what this tells me is that I need to break up my middle terms into these two quantities. So take a look at the middle term here, break it up. So now we're going to have 4x squared minus 14x plus 6x minus 21. Okay, again, I'm taking these two quantities and making them my coefficients now. And then I can do grouping. So here, what can I factor out? Put my dashed line in. What can I factor on the left side? I can clearly factor out a 2x. And I'll be left with 2x minus 7. On the right side, what can I factor out here? Well, I take a look, I see it looks like a 3. So I take out a 3, I'm going to be left with 2x minus 7. Oh, coincidence? I think not. 2x minus 7 has to appear twice in order for grouping to work. So I see that there's really a positive sign in front of that 3 there, because I took out a positive 3. So one of my factors will become 2x plus 3. Well, where does that come from? The 2x comes from here, positive 3 comes from there. The other factor is the one that repeats itself, because you're really factoring it out now. So you have 2x minus 7. So 2x plus 3, 2x minus 7. Choice C. If you got stuck and you were really confused for this problem, all you need to do is actually just FOIL everything out, but that takes a while. You could FOIL this quantity out up here, FOIL this one, and this one, and see which one works. Okay? If none of them work, then it's choice E, not factor. Number 9. Which of the following gives a solution set for the equation quantity absolute value of x plus 3 over 2, close absolute value, equal 5. Remember, absolute value means it can be plus or minus. So simply start by rewriting. And I know I'm going quick here, but this is all in your notes. We went over this. Start by rewriting this as a positive and a negative 5, and then just solve simultaneously. Move the 2 up, you get x plus 3 equals 10. You get x equals 7. Move the 2 up, you get x plus 3 equals negative 10. Thus, x equals negative 13. Negative 13. Okay? So for a problem like this, we have 7 and negative 13, which is choice C. All right. Number 10. What are the roots of 3x squared plus 6x minus 5? So some people might say, all right, well, you know what? Mr. Howell said when AC method, when we have this problem with a non-unity A, use AC method to factor. But this says find the roots. So you can do one of two things. You can start with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's my quadratic formula. But you know what? If you don't want to do that, if you remember this year, we wrote that program in our calculator, and you want to find the roots of it, just go ahead and type it in your program. The problem is that your answer is not going to necessarily look like what you have on the paper here as our choices. So let's go ahead and do the quadratic formula first. We can see. X equals negative 6 plus or minus the square root of 6 squared minus 4 times a times c all over 2a. Well, okay, it looks like I'm going to have a 6 in the denominator. Under the radical, I'm going to have, this is going to give me 36. There's a minus sign here. 4 times 3 is 12. 12 times 5 is 60, so this is going to be a negative 60. So I'm going to really have 36 minus negative 60 as a radicand. That's what's under the radical, which really tells me to add. So I'm going to simply have 96 under the radical now. But still, take a look at this answer. It still doesn't look like my choices at all. It really doesn't. But use the process of elimination, people. You don't even have to go further. Break this up. Think of this as x equals negative 6 over 6 plus or minus root 96 over 6. Well, what's negative 6 over 6 right here? This is just negative 1. So right away, you're going to have a negative 1 in the front and a plus or minus. These are the only choices that have those. So rule these out, please. Okay, why am I ruling them out? Because take a look at the problem here. I can't simplify radical 96. It can be broken down further, but it's not a perfect square. So I'm going to be left with some sort of a radical. If I were to simplify radical 96, I could think of it as, I don't know in this case, let's see, 6 times 16 it looks like? Yeah, 6 times 16. So I could write this as x equals negative 1, as we said, plus or minus, and this is going to be 16 times 6 under the radical over 6. Well, square root of 16 is just 4. So again, you don't have to do all this, but I'm just proving. You can get 4 root 6 over 6. 4 over 6, this here is really 2/3. Now, why do I not have to do that? Take a look at choice C. Choice C has an I in it. I means imaginary. Imaginary roots only occur when the discriminant b squared minus 4ac is negative. But take a look, we have a positive 96. A positive. When it's a positive, you will not have an imaginary part, so you could have just ruled this out when you got to this point right here. When you got to this line here, or even this line here, you could have ruled out your imaginary answer, which leaves us with choice B, which is correct, which is the exact quantity we got over here. Let's take a look at number 11. If the area of the figure below is 12, what is the perimeter? Well, this involves geometry, but it's still algebra too. Area equals length times width, so area equals x, quantity x plus 4. Again, the important part here is to know that you're going to distribute here. The area is 12, so we have 12 equals x squared plus 4x. Again, how do I know that? I distributed, and I knew that the area was given as 12, so I plugged it in right there for the area. At this point in time, the problem says, what is the perimeter? To find the perimeter, think to yourself, perimeter is the sum of all the sides. The sum of all the sides. So the perimeter is really x plus 4, because again, this x plus 4 is really down here. You have x here, and you have x here. So plus x plus x. So the perimeter is just the quantity 4x plus 8. But I can't get the perimeter because I don't know the x value. But I do know this equation over here, so go ahead and use this equation to solve. You got, move the 12 over. You got 0 equals x squared plus 4x minus 12. Again, how do I move the 12 over? By subtracting it. Then you can go ahead and factor. What numbers multiply to give me 12 and add up to 4, or negative 12? I'm thinking 6 and 2. Which gets a positive, which gets a negative? Well, I want the middle term to be positive, so the bigger needs to be positive, the lesser needs to be negative, equals 0. Well, now you have a t-chart. X equals 2, x equals negative 6. Okay, that's my t-chart solution. But think, people, please. You can't have a negative x because that would mean that this side length would be negative 6 here. So reject that answer right away. So x is just equal to 2. So I could say, okay, well, this is 2, 6, and 6. That's 12. 12 and 4 is going to give me 16. Or I could just simply plug in the 2 right here into my perimeter formula and get 8 plus 8, which is still 16. Either way, your answer is choice D. Your answer is choice D. Let's take a quick look at number 12. What are the coordinates of the vertex of the following graph? All right. For this problem here, first, there are several ways to do it. You can always graph it and try and find the vertex in your calculator. So let's go ahead and do that first. I'm going to show you to do it by hand, which I would personally do, but I also want you to know that you can graph it. So we've got x squared plus 8x plus 11. Let's get that plus sign. There we go. Plus 11. Zoom 6. All right, so my vertex is in this general vicinity right here. But I want to know what its coordinate is. And if I think about this, the graph is decreasing, then the graph is increasing. And that indicates that there must be what's called a minimum here. We've talked about this in class. When a graph decreases, then increases, that's a minimum. So I can use my calculate function if you want to. Press, oops, let me clear the ink layer. Press second, calculate, and you want a minimum. So look at number 3, minimum. And you want to know the left bound. So they're saying guess some number to the left of it. Well, this is negative 1, 2, 3, 4. So I'm going to guess like, I don't know, negative 6. Or I can just simply move my cursor over. Move my cursor to the left of the minimum. So just put some number in to the left. Okay, enter. Something to the right. And you could put numbers in. You don't have to do the cursor. You can just type in the number, enter. And then it says take a guess. Well, guess somewhere in between. Hit enter. And take a look. There is your vertex. Your vertex is really negative 4, comma, negative 5. Okay, and this is rounding because it's using a numerical technique on the calculator. Now, that's the answer, but let's do it by hand. So negative 4, negative 5 is what we came up with, so we know that the answer is going to be choice C, but how do we do this by hand? So, to do this kind of a problem by hand, we say, all right, well, I have to think about the vertex and the fact that the vertex goes through the axis of symmetry. So whenever I have a graph, and this graph, and we know already what it looks like, but say I didn't know that, that's what it's going to look like. There's my axis of symmetry, and there's the vertex. It always occurs on the axis of symmetry. And the axis of symmetry, if you remember, is x equals negative b over 2a. Well, negative b over 2a means negative 8 over 2 times 1, which is really negative 8 over 2, or negative 4. So the x-coordinate must be negative 4. So right away, you could have ruled out these 3 choices simply by just doing the axis of symmetry and getting an answer over here of negative 4. But I want to know what the vertex is going to be, so I need to know the y-coordinate. So take the negative 4, plug it back into the function to get the y value. Negative 4 squared plus 8 times negative 4 plus 11. This is going to be 16 minus 32 plus 11. 16 minus 32 is negative 16 plus 11. Now, negative 16 plus 11, I start at negative 16, I go up 11, which is going to bring me back to negative 5. The common mistake is negative 7 here, because people see 6 and 1 and they think of 7. But negative 16 or negative 11 is negative 5. Again, reinforcing the answer is choice C. Number 13, the area of a rectangle is 144, j to the 9th, k to the 15th. If the width of the rectangle is 8, j to the 4th, k to the 5th, what is the rectangle's length? All right, so think back. Again, geometry. Area equals length times width. Okay, it's got to be memorized by now. You know rectangle is always length times width. We know what the area is. The area is 144, j9, k to the 15. And that equals the length, which is what we're looking for, times the width. 8, j to the 4th, k to the 5th. So at this point in time, I'm looking for L. So I want to get rid of what's next to L, and it's currently being multiplied. So let me divide. Divide by 8j to the 4th, k to the 5th. Divide by 8j to the 4th, k to the 5th. Cancel, cancel. You're left with L over here. Well, take a look, people. We have to simply just divide these two. Okay, just divide them. So I see I have 9 j's up top, and I have 4 j's down below. So there's really, like I'm saying, I have 9 of them. 9 j's up top, and 4 down below. So these 4 cancel with these 4. I'm left with 5 j's up top. Look at your answer choices, everybody, right away. The only one that has j to the 5th is C and D. So these are out. Okay, those are both gone. I don't know about E yet. Next, I want to find the k value. Well, there's 15 k's up top and 5 down below. 15 and 5 reduce. You're left with 10 k's. Well, where are you left with the 10 of them? Up top. Well, take a look. They both have 10 k, so that doesn't help. Or k to the 10, so that doesn't help me yet. But everybody, what's 144 divided by 8? It's 18. Okay, it's 18. If you did 144 minus 8 by accident, you would get the 136, which is choice C. Okay, so the answer in this problem is choice D. Choice D. What is the relationship between the lines 3y equals x minus 3 and 2y equals negative 6x minus 2? Are they parallel, perpendicular, askew? Are they the same line, or none of the above? Let's take a look. Easiest way to do, solve for y. Divide by 3, divide by 3. You get here, y equals, these 3's cancel, x over 3 minus 3 over 3. Okay, that's the first one. Well, I think of this as y equals 1/3 x, because that's what x over 3 is, minus 1. On the right-hand side, divide by 2, divide by 2. You get y equals negative 3x. Let me write it out first, and then I'll go to the answer. Sorry. Negative 6x over 2 minus 2 over 2. Well, this is going to be y equals negative 3x minus 1. They're both minus 1. Oh, that doesn't matter. It's the slope that matters. Take a look at your slopes. This has a slope of 1/3, a slope of negative 3. And if you remember, the slopes of lines that are perpendicular are negative reciprocals. Well, what's the reciprocal of 1/3 is just 3. So the negative reciprocal is negative 3. So these lines must be perpendicular because they are negative reciprocals. Remember, if you have 1/3 and you want the reciprocal, it's 3 over 1. But we want the negative reciprocal because it's perpendicular. It happens to be the negative reciprocal. These lines are indeed perpendicular. Had they been parallel, the slopes would have been identical. Had they been the same line, the slopes would have been identical and the y-intercept would have been identical. Number 15. If f of x equals x squared plus 10x plus 24, and f of x crosses the x-axis at which of the following points? Okay, which of the following points? So, for a problem like this, we have to think to ourselves, crosses the x-axis. What does that mean? Well, I think it means it has an x-intercept, right? X-intercept. So let's take a look and factor this. Let me write f of x, even though y equals the same thing, just to be consistent. All right, well, 24, what are the multiples of 24? You can do 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, that's pretty much it. Now, out of those combinations, which of those are going to give you 10? Well, these add up to 25 or 23. These two add up to either 10 or 14. These two add up to either 11 or 5. Well, take a look at these ones. Those both add up to 10, don't they? But I want to know I have a negative 10. So I should put a negative 4 and a negative 6. So when they add up, they become negative 10. But when they multiply, they become the positive 24. At this point, make a t-chart. X equals 4, x equals 6. So you have two solutions, 4 and 6. But which choice is there? Only 6. Be careful. This is the common mistake right there. Okay, it's not negative 4, it's positive 4. But that doesn't show up, so the only x-intercept that matches up with my multiple choice is x equals 6. Number 16, simplified. 27 to the 2/3. Please start by rewriting in radical form. Think of this as 27, okay, to the second power with a cube root. Okay, remember, the denominator becomes the index, the numerator becomes the answer. Okay, so what is the third root of 27? That really means what number times itself 3 times gives you 27. Well, 3 times 3 times 3 is 27. So the cube root of 27 is simply 3. 3 squared is 9. Choice E. Let's make believe you had a brain fart. You forgot how to do this. Well, 27 to the 2/3 was the original way we started this problem. You can go ahead and type in your calculator. Let's do it. Second quit. Let's go to our home screen. 27, caret. Now, how do I write 2/3? I need a parentheses. Okay, with the parentheses, I'm going to get my answer of 9. Let's do it and make believe we forgot the parentheses here. If I have forgotten the parentheses, it's going to do 27 squared and then divide that by 3, which is very different. Again, our answer is 9 because we knew that we need parentheses here. We need the parentheses. All right, let's take a look at number 17, solve for x. For a problem like this, you can either find a common denominator of both sides or cross multiply. It doesn't matter really. You can do it either way. I would say, well, what's missing on the right side? X minus 6 is missing here, so I put it on top and below. Here, x plus 1 is missing. And remember from class, we talked about when you have the same denominator of an equation, you can just drop off the denominator. So cancel them out. You're left with x plus 1 and 2. You're left with negative 5 and x minus 6. Well, that's the same thing you would get if you cross multiply. Try it. Try it on your own. Cross multiply, you get the same exact equation. At this point in time, let's distribute. We get 2x plus 2 equals negative 5x plus 30. Combine like terms. I'm going to bring the 5x over here as a positive, making that a 7x. I'm going to bring the 2 over as a negative, making that a 28. So thus x equals 4. Okay? Choice B, x equals 4. How do I know that that answer makes sense? I can check my answer in my original equation. Okay, I get 2 over 4 minus 6 equals negative 5 over 4 plus 1. This is going to give me 2 over, what's 4 minus 6? That's negative 2 equals negative 5 over 5. Well, this is just negative 1 equals negative 1. Check, it does work. Okay, so please make sure you check your answers. Number 18. Let's see what we got here. We've got a log problem. We've got a log problem. And we just did logs the other day. So for this problem, we can see that there's an x in the argument here. So I can't get that x by itself. So I might want to convert this back to exponential. But before I can do that, I see this 5 is here is being multiplied. So let's divide by 5. We get log base 3 of 3x plus 12 equals 2. Okay, 10 divided by 5 is 2. Well, take a look. I want to know what the x value is. I still can't find it, and I can't use my calculator. So let's write this in exponential form. The base remains the base. The answer becomes the exponent. The argument becomes the answer. And now I can easily solve. I got 9 equals 3x plus 12. Subtract the 12 from both sides. Subtracting 12, or moving the 12 over as a negative, I get negative 3 equals 3x. Thus, x equals negative 1. And again, x equals negative 1. Choice E. All right, let's take a look at number 19. Number 19, the value of log base 1/9 of 3 is exactly which of the following. Well, there are two ways to do it. One way is to do change of base. Do log of 3 over log of 1/9. Type it in your calculator, get an answer. That's one way of doing it. Or you could say to yourself, is set this equal to x, and then rewrite it as exponential. You got 1/9 to the x equals 3. It's still a little bit tough, right? Well, I know that if I have a quantity here that's going to be in my denominator, the only way that can happen is if I have a negative exponent. So for this kind of a problem, I want to think of this as a negative quantity right away. Well, if it's a negative, it'll move it up, but I want it to become a 3. So this is going to end up being negative 1/2. So because 1/9 to the negative 1/2 is really saying 1/9, is really saying 9 to the 1/2, and a 1/2 really means a square root, which is really saying 3. Okay, so it's negative 1/2. It might be easier to use change of base for this example, okay? Again, do whatever's easier for you here. Number 20, if f of x equals the square root of x minus 2 and g of x equals the square root of x squared plus 11, find the value of f of g of 5. Remember, these are compositions. Take the 5, plug it into g, get an answer. Take that answer, plug it into f, get an answer. So let's start by plugging a 5 in right here in g. I get 25 plus 11, which is 36. Radical 36 is just 6. So that's the answer I get there. Now take the 6, plug it into f. So put a 6 in here. 6 minus 2 is really 4. The square root of 4 is plus or minus 2. Well, the only answer on here, not obviously is both of them, is just one of them. Or both of them are obviously not on there, just one of them. And I can see that my answer of positive 2 is the only choice in this problem. Okay, so again, compositions. Inner to outer. Work your way out. Inner to outer. Which of the following is the correct simplification of 2 minus radical 6 over 4 plus radical 10? This is our example of binomial conjugates. Binomial conjugates. We're going to have a function here when we're going to look and try and figure that out. So again, we have a binomial conjugate here in the denominator. So we're going to see we have 2 minus root 6 over 4 plus root 10. We talk about rationalizing a denominator, so let's multiply by the binomial conjugate. 4 minus root 10 over 4 minus root 10. Up top, I'm going to have to FOIL this. So remember, think of this with parentheses, FOIL. Up top, you're going to get 8. That's the first. Then the outer is going to give us negative 2 root 10. Then the inner is going to give us negative 4 root 6. And then the last is going to give us positive root 60. All over. Now the bottom you have to FOIL also, but remember the inner and the outer cancel. So first you're going to get 16. Inner is going to be, outer is going to be negative 4 root 10. Inner is going to be positive 4 root 10. So those cancel. And then I'm left with just minus the square root of 100. Again, you're going to really get 16. If you FOILed this out, this is what you would really get. But remember that these middle terms drop off, so I really don't care about them. So this is really 16 minus 10, which is positive 6. So I'm going to end up with 8 minus 2 root 10 minus 4 root 6 plus root 60 all over 6. But look at the answer choices. That's not a choice here. Okay? It's definitely not a choice. And this says the simplification. So we have to simplify this further. I can see the 60 there and break that into 15 and 4 and then possibly reduce. So, but just look at all these other values. When you reduce all these by 2. This is going to become 4 minus root 10 minus 2 root 6. This is going to be a 3 down here, and then whatever you get over here. And the only answer that has a 3 in the denominator is choice B. Okay, and everything else matches up. It's going to be choice B. And if you broke up the 60, you're going to break this into 15 times 4 under the radical, which is really becoming 2 radical 15. And the 2 cancels to leave you with just the radical 15 there, which is this component of the answer. Okay, you have to simplify completely. That's the key there. For number 22, which is true about the solutions of the following equation? All you got to remember here is discriminant. What is the discriminant? So we got b squared, which is 16. Okay, so 4 squared minus 4 times a times c. This is going to give you negative 8, so 16 minus negative 8 is positive 24. When the discriminant is positive, you have 2 real solutions. Remember, 2 real solutions. If the discriminant were 0, you have 1 repeated solution. If the discriminant were negative, you would have 2 imaginary solutions. When are there no solutions? Well, there's always solutions to these problems. Some of them just could be imaginary, okay? So in this case, we have 2 real solutions because our discriminant is greater than 0. Okay, they're real, and they are 2 distinct solutions. What is the correct factorization of the following? Well, this is a tough problem. The reason it's a tough problem is because you have to start by looking at this problem and saying to yourself, well, I might need to use a synthetic table. So you can use synthetic table or we can graph. So if I start with synthetic table, I got 1, negative 4, 16. Okay, I bring down the 1 by 1 is 1, 1 minus 4 is negative 3. It's going to be negative 3 minus 4 is negative 7. Negative 7 and 16 is going to be a positive 9. Well, that's not a root, so that doesn't help me much. The signs aren't alternating and they're not the same, so I don't know if it's an upper or lower limit. So let me go to the next number. I'll try 2 next. Bring down the 1. 2 times 1 is 2. 2 minus 4 is negative 2. 2 times negative 2 is negative 4. Negative 4 and negative 4 is negative 8. Well, negative 8 times 2 is negative 16, and 16 is 0, which tells me that is a root. Well, if 2 is a root, again, 2 is a root, that means that x minus 2 must be a factor, because I remember the factors and the roots have opposite signs. What is the only answer choice with x minus 2 as a factor? Choice D. And you can know this by doing the following. Bring this down as x squared minus 2x minus 8 here. Bring all 3 of these down, and then factor that. What numbers multiply to negative 8 and add up to negative 2? Well, I'm going to look at 4 and 2. It's going to be x minus 4, x plus 2, which I can see also shows up here. Another way to do this problem, if you ever want to find the factors, just find the roots first, like we said, and then switch them. So go to your graph now. Go to y equals. Let's clear it out. Let's type in x to the third minus, let's try that again, minus 4x squared, where are we, minus 4x plus 16. zoom 6, and let's take a look at where my roots are. So I've got roots at -2, at 2, and at 4. So roots are -2, 2, and 4. So my factors must be x plus 2 from here, x minus 2 from here, and x minus 4 from here, which is still choice D for this problem. Still choice D. Let's take a look at 24. What is the quotient of the following? Remember, when you divide by a fraction, you multiply by the reciprocal. X plus 6 times x squared plus 7x minus 8, x squared plus 5x minus 6. So remember, multiply by the reciprocal. Please, please, please take a look. It's easy to factor this. Okay? We think right away you're going to have to cancel something. So in the numerator, what numbers multiply to 8 and add up to 7? It's going to be 8 and 1. So we got x plus 8, x minus 1. In the denominator, we're going to see we're going to have to multiply to 6 and add up to 5. That's going to be x plus 6, x minus 1. Well, take a look. X minus 1's cancel. X plus 6 cancel, because this x plus 6 is really over 1. You're left with x plus 8, which in this case is choice C. Okay, choice C. Let's take a look at the last two multiple choice, then we'll take a little break until we get to our next video where we'll answer the graphing and the free response. What is the simplified form of the following? All right, well, I've got an exponent on the outside. Let me start by distributing that. So when I distribute an exponent, I have to remember that I'm going to be multiplying those powers. Well, before I do that, actually, let me look at the denominator. See that -1 there? I'm going to distribute that. So in the numerator, I'm going to still have x squared, y to the -3, all to the 5th. Denominator, I'm going to have x -1, y -4. Now let's distribute the 5. Distributing the 5, I'm going to get x to the 10, y to the -15, all over x to the -5, y to the -20. Well, when you have a negative x, it's a -20 there, -20. When you have a negative exponent, you think of it as a positive and switch it. So the x to the 10 stays up top. The x to the -5 that was in the bottom moves up top. The y to the -20 also moves up top as a positive 20. And the y to the -15, it moves down below as a positive. Let's see what happens next. X to the 10, x to the 5 means we really have 15 x's. Here we've got 20 up top and 15 down below. Those reduce, leaving behind 5 up top. Okay, so we have x to the 15th, y to the 5th, choice C. Choice C. And finally, the last problem, which is coming from concept 57, our log properties. Remember, our log properties tell us the following. When we see things in the numerator, we can think of them as a positive. In the denominator, think of them as a negative. So I start by writing this as negative log base b of x squared plus log base b of y minus log base b of z cubed. Again, whenever you see a product, you think of it as a sum. This product up here, I think of this as the sum of these two. This is a quotient or a denominator. Think of that as a negative. Well, when you see an exponent up here, remember our rule is we could bring the exponents in front. So let's bring those in front. So we have negative still, 2 log b of x plus log b of y minus 3 log b of z. Well, those were all given definitions in the beginning, so now let's plug them in. Log b of x is 2, so put a 2 in right here. So we got 2 times 2, really. Here, log b of y was 3, so it's just plus 3. Finally, log b of z is just 7, so minus 3 times 7. Okay, so we have negative 4 plus 3 minus 21. 4 plus 3 is 7. 7 minus 21 is negative 14. Well, negative 14 is simply positive 14. Okay, this is the first half of the answers to your sample questions for your final. I'm going to stop the video now and record the rest later. We're going to do the graphing later, and we're going to look at the free response later.